Okay, we'll continue this session. So we have seen this bending moment at the point B due to this vertical loading. Now we'll find this bending moment at the point A due to this vertical loading. So the equation it is RCV into 300. That is this force upward reaction into the distance between those 2 points, that is 300. So that value we can calculate it as 6,9. So here we can substitute that reaction, that is RCV, we are having it as 2316.02 into 300. So the answer it is 694,806 Newton millimeter, or we can write it as 694.8 Newton meter. So we have found out this vertical bending moment at the point A and B because of this vertical reaction. Now we will plot this value in this diagram, the vertical BM diagram. So here we can mark this point A, already having this point A and B. We have found out these values. So we will show that magnitude here. At this point A we are having 694.8 Newton meter. At this point B, the vertical bending moment value, we are getting it as 198.5 Newton meter. And point D and C, the bending moment is equal to 0. So proportionately we are marking this point 694 and 198. Now we can join this point with a straight line. So I'll join these points here, and similarly this point, and then I can join it to the point D. Now I can have this. So this is our vertical bending moment diagram. Here at this point A, we are having this maximum bending moment. But we are having this horizontal bending moment also. So we have to find that value and we have to find out the resultant. Then only we will understand which point is subjected to the maximum bending moment. So we will again go back to this slide and we will see this horizontal bending moment. So here I am having this reaction RCH, and this is RCRDH, and this point is A and this point is B. Here we are having only this vertical force, the horizontal force at the point B, and that magnitude we are having it as 4964.13 Newton. So again the same procedure, the reactions at the point C, horizontal reaction RCH plus the horizontal reaction at the point D is equal to horizontal force, total horizontal force acting. This is equation number 6. Now to find out any one of this force, we have to take the moments about any one of these points. So I'll take this moment about this point C. So I can write it as RDH into 1000. That is the distance between this point C and D, 1 meter. So it is RDH into 1000, that is equal to 4964.13 into this distance. So we know that the total distance is 1 meter and this distance is 200 millimeter. So that means it is 800 millimeters. So the value RDH is equal to 3971.33 Newton. This is a reaction at the point D. Now if we substitute this value in this equation, we can find out this reaction acting at this point C, that is RCH is equal to 4964.13 minus 3971.33. So we will get this value as 992.83 Newton. So we got this horizontal reactions at this point C and D. Now we have to find out the bending moment at this point A and B because of this horizontal reaction and horizontal force. So as I said earlier, the bending moment at the point C and at the point D, this will be, that is MCH is equal to MDH. Bending moment at the point C and D due to this horizontal force is equal to 0. Now we have to find out the bending moment at the point A, that is MCH, MAH. Here also we can take this moment. If I take it from the left side, it will be RCH into this distance, 300. If I take it from the right side, I will be having this RDH into this distance, and I will be having this 4964.13 into this distance. So this will be easier because I have only one force to work from this direction. So I will write it as RCH into 300. So the value for RCH, we already calculated this. So it is 992.83 into 300. So I am getting this value MAH as 29784.9 Newton millimeter, or it is equal to 297.8 Newton meter. So we have calculated the horizontal bending moment at the point A. Now we will find out this horizontal bending moment at the point B, MBH. So here also, if I take it from this direction, it will be RDH into 200. If I take it from this direction, it will be RCH into this distance, total distance. So I am taking it from this direction, so it will be RDH into 200 millimeters. So if I substitute the value for RDH, that is 3971 into 33 into 200, I will get this value as 794266 Newton millimeter, or it is equal to 794.2 Newton meter. So we have found out the bending moment produced by the horizontal load. Now I'll go back to this diagram and we can represent that here. At this point, horizontal bending moment diagram. Here at point A, I am having the moment as 297. So here it is, I am having a value that is, draw that here. It is proportionately, I'll mark a point here. It is 297.84 and here it is 794.2, and at the point C, as we know, and D, it is equal to 0. Now I can join this point C and this point, straight line. This is also a straight line, and this point B is joined to the point D, that is also a straight line. Now in between portion I can hatch it. So this is a horizontal bending moment diagram. Horizontal bending moment produced by the horizontal force. Now we have to find out the value, that is a resultant bending moment produced by the vertical and the horizontal force. So we will calculate that value. So for that, we have this equation. The resultant bending moment, I will calculate this value here. The resultant bending moment Bm at A. Resultant bending moment at A. So I can represent it like this, MA. We don't have a V or H. V stands for vertical, H for horizontal. Now it is only A. That is the bending moment at the point A. That can be found out using this equation. Sigma square root of MAV square plus square root of MAH square. And I can substitute the value, that is 694.8 square plus 297.84 the whole square. Now it is square root, and this value I am getting it as 756.56 Newton meter. So this is a resultant bending moment acting at the point A. And now I can calculate this resultant bending moment acting at the point B, that is square root of MBV square plus MBH square, and if I substitute that value, it will be square root of 198.5 square plus 794.2 the whole square, and the answer will be 819.2 Newton meter. So here I can represent this torque here. So point A, at this point A, I am having 756 Newton meter. At the point B, I am having 819.2 Newton meter. This also I can draw.